Welcome to episode 152 of the G2 on 5G. It's the latest inside scoop on everything 5G. We cover 6 topics in about 20 minutes, and it's brought to you by More Insights and Strategy. I'm Will Townsend, and joining me again this week is fellow analyst Anshel. Let's get started with my first topic, and I want to talk about Intel. And this is actually a Fierce Wireless article that broke late last week, and Intel is talking about 5G and how that could potentially serve them as an incremental revenue opportunity. And there's been you and I have talked a lot about Intel and 5G in the past, but what I found interesting, so this was Martha DeGrassi, who I have a lot of respect for her at Fierce, but she had a chance to talk with Intel. And at a high level, the big takeaway from her article for me was, obviously Intel is very focused on mobile edge computing, with their CPU lineup. But they're also indicating that when they're having these MET conversations, it's beginning to open discussions up around 5G private wireless. And I'm not surprised to hear that, because you and I have talked about how MEC can supercharge a lot of 5G use cases, and we're seeing that happen in the wild. But I just thought it was interesting that Intel sort of validated, what you and I have discussed in the past. So I don't know, any thoughts there? Are you surprised to hear this, or?
No, I mean, when you think about Intel's strengths, private networking is definitely one of those things where I think they benefit the most.
Yeah.
And I think there's still a very large untapped market there. And I think if they really position themselves right and have the right partnerships in place, I think they could benefit greatly from the growth of the private 5G sector. Now, that really does depend a lot on the integrators.
Right.
And I think, making sure that Intel has good relationships and has a place in those integrations is key. But I honestly think the world of private 5G is big enough that everybody has an opportunity.
I would agree. And I'm actually working with the Multiplier Alliance on their efforts around what they're doing to sort of drive private networking. And they've actually published 5G blueprints. So I don't want to, steal all the thunder from this, but I'm actually working with them on a research brief that'll be published in the coming weeks. And so more to come there. But let's go to your first topic. And it's that time of year again, Ookla. And they just published a report. I caught this as well. And they're basically ranking T-Mobile above AT&T and Verizon, but I'll let you go into the details there.
Yeah, I'm going to make this quick. T-Mobile crushed download speeds with Ookla, which they did pretty well. Actually, the results here show a lower speed for T-Mobile than they did in the report we saw from OpenSignal last week. They're saying 160 instead of 200. However, the gap between them is also wider, with Verizon and AT&T having much lower speeds. And then upload speed, T-Mobile actually wins here, which is interesting because we saw with the OpenSignal test, they lost to Verizon. Here they win handily, but honestly, all carriers look quite bad. T-Mobile's upload is 12 megabits. Not a great result. I think a lot of that is probably being driven by the fact that Ookla might be having a broader database of users that are probably mostly using low band to do tests, and that is affecting how much uplink you can get. Because for my experience, when I'm on T-Mobile or Verizon, I'm getting over 100 megabits per second upload. So I think that's a huge factor, is this might be more of a low band phenomenon. They also did multi-server latency. T-Mobile won there as well. Whatever they call consistency, T-Mobile wins there as well. Video score, T-Mobile also won. And they also won in 5G video score and 5G performance. Here in 5G performance, they actually showed 220 megabits per second, which is actually faster than what OpenSignal was showing. Verizon was getting 130 and AT&T was getting 86, which kind of aligns with the state of all of these 5G networks. If you were to put a calendar of how many months that they've been building their 5G networks, it would almost look like the exact same bar between their actual total speeds and how long they've had to build out their networks. So I think that's something to consider as well. But T-Mobile is kind of running away with it. They are lowest in latency, highest in speed and consistency. They kind of just clean things up with this test, which I don't think anyone's really surprised by.
Yeah, and I think, you know, when you make that comment, just to clarify for our viewers and listeners, you know, depending on where, you know, Verizon and AT&T are at with their mid-band spectrum build out, right? That's going to drive, you know, uplink and downlink. So, yeah, that's not surprising. It's pretty predictable. You know, if you sort of follow the cadence there, and certainly T-Mobile has been ahead of both in the US with respect to, you know, fully building out their low band and mid band assets. And I agree with you. The lower uplink is probably, you know, when Ookla did that, that was probably on, I would assume, low band, right?
Well, they're probably also using low band for uplink right now.
Yeah, good point. Okay, yeah, and that's always what you have to do on, you know, these speed test evaluations, is you have to really sort of dig in to the methodology to really understand, you know, the method to the madness there. But well, hey, let's go to my second topic this week, and your second topic is interrelated to this one. But I wrote a Forbes article last week, and I sort of talked about the fear, uncertainty, and doubt that's abounding in the RAN market. And so there was a published market report by Del Oro Group, and they talked about, and it's not surprising, they talked about how basically over the last 5 years, RAN spend has averaged 40 to 50% year over year. And that makes a lot of sense, because if you go back 5 years, that's really when, you know, 5G networks began their build outs. And what they're predicting over the next 5 years, from 2023 to 2028, I guess, if my math is correct there. Math is not my strong suit, but that's pretty simple arithmetic. But they're predicting flat to negative growth in RAN. And so it, you know, it sort of got me thinking, because you're going to talk about Ericsson and Nokia. So Ericsson had announced earnings earlier that week. They were down, but they were within guidance, but the stock took a hit. And then Nokia is actually announcing, I believe, today or tomorrow. And Nokia took a hit as well. And so, you know, my hypothesis was, you know, the market saw this report that was published. And even though Ericsson delivered at guidance, the stock took a hit, and Nokia took a hit as well. So I don't know if you completely agree with that hypothesis, but that's a great setup for what you want to talk about and go into a little more depth about.
I was going to say that, sorry, I have an alarm that went off at the worst possible time.
Of course.
I actually think this is my hypothesis.
Okay.
And this is based on what the current state of the 5G market is. And I'll say my topic is that Ericsson and Nokia both lowered their expectations, which is very similar, but maybe a little bit less on the nose about RAN specifically, and your Forbes article, which I do recommend people read. But I actually think the issue is that operators spent all of their CapEx on RAN and not enough on core. And because we had such a heavy RAN deployment and everyone was looking to build out coverage first and foremost, we didn't actually build the standalone networks we were supposed to have,
right,
I don't know, 2 or 3 years ago. And I'm sure the pandemic is a factor in that. But the way I look at it is, we don't have the 5G applications people want today. People get 5G as just a faster 4G, or in some cases a slower 4G. And I'm actually writing an article about this right now. I'm about halfway through it. Should have finished it last week. That's my own problem. But the way I see it is, we've underinvested in core. And because we've underinvested in core, that investment has happened in RAN. And because there's not enough core investment, we don't have enough standalone networks to actually enable the 5G applications that everybody's been promised since we started talking about 5G, 7 years ago. So I think this is a consequence of not spending CapEx where it was needed, and instead spending it in places where you get to be able to claim faster speeds and better coverage. Because realistically, consumer won't really understand or care about latency or network slicing, but those are the things that drive the new applications.
You know what? I think you're spot on. I think you and I can be, we can agree here on a couple of points. And it's interesting because when you sort of look at, this non-standalone versus standalone with 5G, non-standalone is when you focus on the RAN first, and you get the towers all lit up with 5G infrastructure. And then, once you bring, the core up to speed, and match it, that's when you get to standalone. So I completely agree with you. I mean, the focus from a CapEx perspective has been on the RAN, so they could check the box on 5G
Speed
non-standalone.
tests.
Yeah, yeah, and the speed tests are reflecting that. So I think you and I are both right in some ways with both of our hypotheses. So good stuff, my friend. Let's move to my third and final topic. We're being quite snappy today, and I want to talk about AT&T. And I caught this news. It's our good friend Mike Dano at Light Reading, who has been a guest host on our podcast in the past, and he had a chance to speak with AT&T to talk about 5G battery life. And there's some pretty widespread acknowledgement that 5G devices basically are draining battery cycles much more quickly than LTE. And Mike actually points out that on the iPhone, that basically sort of like when the iPhone launched many years ago for mobile offload, the default was to Wi-Fi, right, in your home. And sort of the same thing is happening here, where there's a sort of a default to 5G auto to conserve battery life. And what AT&T plans to do, they're going to actually release a couple of different network updates in the coming months. So, and what they're stating is that there's a solution called bandwidth part switching, which is a new 3GPP feature. And the article, Mike talks about how it can enable AT&T's network to modulate its connections to provide speed when necessary and back off and preserve battery life when possible. And he said there's another solution under review, which would be RRC in active mode, wake up signal WS, thermal management, and 5G reduced capacity RedCap, which I am familiar with, which could help with customer battery life. So I think this is all really interesting. I really haven't been monitoring this because you're really our device expert in the firm. But one of the things that 5G has been promising, at least the new radio standard relative to 4G, is better battery life and better power management among its other superpowers. So I found this really interesting. I know you've got an opinion on this, so I'll let you weigh in.
Yeah, I think, part of the problem is we look at 5G and compare it to 4G, when in reality you have so many different bands of 5G that operate differently. Like, I would not compare 5G millimeter wave to 4G power consumption, right? Because you have so much more throughput.
There's no comparison. Yeah, right? Millimeter wave is a new element within 5G.
When we talk about comparing 5G power consumption to 4G, we should really be looking at, bits per joule. And like what kind of efficiencies are we getting out of that? I have a strong feeling that a big component of why 5G is consuming more power than 4G is also because when we're lighting up 5G today, we're still keeping on 4G as well, and having to be able to connect to both networks simultaneously. My understanding is a big component of this power consumption. So if we can enable users to maybe set 5G on only when signal is bad to switch to 4G, that might be a power saving opportunity as well. I don't think this problem has been researched well enough, that I think, I know that the 3GPP has a lot of solutions for it.
Yeah.
I also feel like when you look at the RANs that exist today, a lot of those are still using 4G LTE backhaul, and they're using 4G LTE core. So we're still not in a place where I think it's fair to compare 5G to 4G. I would love to see a 5G SA, pure 5G SA comparison to a 4G LTE network in a similar band, not on the same band, because then you'd be doing DSS. But I would love to see the like for like comparison at the same frequency, same power, and see, okay, are we actually consuming more power, and is it meaningful, and why are we consuming more power? So I also think the size of the batteries today are gigantic.
Right.
We also look at the portion of the smartphone's battery consumption, still predominantly the display. So you would have to be, using a device for a very long period of time to actually have the modem be the problem. And generally, a modem is only the problem when you're actively using the device or you're in a bad signal area. And if you're in a bad signal area, nothing's going to save you, 4G or 5G. So I think there might be good things that are coming down the road. And I think RedCap is a big one of those things. But I think RedCap is going to mostly be for IoT applications and private 5G to enable longer battery life. And it'll beat 4G in efficiency. So I have a little bit of hesitance to necessarily give 5G as much of a bad rap as I think some people are trying to do. I also think that millimeter wave, it's just a totally different profile. And that's why I think if you look at Verizon, they've done a lot of management of that power consumption because it's so hungry. But they don't turn on millimeter wave until you absolutely need it, until you're doing something active. Then they flip it on and then they turn it off. Like they're not constantly, pinging the towers trying to find a millimeter wave signal and maximize your performance constantly. So there's already some tools in place, and I think maybe AT&T, doesn't have that kind of tool in place because they don't have a millimeter wave network like Verizon does. But I think each carrier has a different, frequency holdings that it really changes how they build out their 5G network and how it behaves. And that's why it's really important. I personally have one device on each network just so I can kind of experience what every carrier is doing and how they're doing it differently. So I think that's a part of what I do. And I advise other people who are in our industry to do the same.
Yeah, you've got plenty of toys to have that flexibility, my friend. So, and you make a really good point because, most of these devices on most of these networks are hitting both 4G and 5G networks. And you're also spot on with millimeter wave. I mean, it's the performance is blazing fast. The propagation is challenging, but it does consume a lot more power. So I would agree with you. Great insights there. Well, let's hit your third and final topic. And I did catch this news as well. So you want to talk about the FCC granting some experimental 5G broadcast licensing to a TV station. And we were talking before we started recording the podcast today, and this is a topic that I covered a few weeks ago as well, but it seems like this use case is going to broaden out a little bit, but I'll let you take it.
Yeah, so this 5G broadcast is something that they're testing in Boston. It's a downstream only technology that would complement existing 5G networks. And the way is to kind of supplement broadcast downloads so that it can take some stress off the 5G networks to improve congestion. And this would be using, UHF frequencies. So it would be kind of a lower band in terms of frequency. So it wouldn't really add that much, but it could potentially, in a very densely populated area, maybe create some alleviation. And there's even talks about using this to do traditional TV programming and broadcasting over 5G to even more consolidate the spectrum that's being used to broadcast TV. And apparently, part of this article that I read from Light Reading, it's kind of been all over the industry, but they're talking about how Qualcomm's also on board to supply Android phones with the software that can use this 5G broadcast to filter the UHF frequencies, and that they will be doing a trial with receivers and set-top boxes in the near future for these 5G broadcast signals. You could also see this being used, in stadium. This was something that was talked about with 4G actually as well. They were talking about doing LTE broadcast. It never really took, but I think really these broadcast technologies could be used to, simplify how streams are reaching users and what kinds of devices could use them. Because if suddenly, these broadcast stations and other technologies become, 5G standard as a broadcast, then you could potentially just pop on, open it on your phone, and
Yeah.
be able to watch those things on your phone, and it would actually almost become like kind of like radio has become for cars, where it's ubiquitous because everybody uses the same standard for HD radio. We could see that happening where you could, have your phone or your tablet with 5G could easily access those broadcasts, and you could have different broadcasts in different places, and it might actually fulfill the vision that 4G broadcast had.
It's interesting, and it presents a monetization opportunity for all of the broadcast television infrastructure that's deployed anywhere. I mean, we're talking about the United States here in this example, but and obviously there are different standards for transmission in Europe, PAL, I believe. But this, number one, could be an interesting monetization opportunity for sort of, I was talking about mobile offload earlier. This is almost like spectrum offload, right? And it's definitely going to be lower band frequency, so the performance isn't going to be that hot, but it's quite interesting. So we have this phenomenon going on, and then we've talked about satellite communications, and I'm actually working on a follow-up story to that Forbes article that I wrote about AT&T and AST Space Mobile. That'll probably be coming out in the next couple of weeks. So that's all I can say on that subject. But it's interesting how these different things are coming together, and now with new funding coming out of the federal government for broadband and for digital divide. I mean, it just seems like all these elements are coming together, and I think we have a solid opportunity to finally bridge that digital divide. It's pretty exciting.
It is.
Well, awesome, my friend. Well, we were very efficient this week. Another great podcast, but why don't you take us home?
Absolutely. We hope our viewers and listeners found this week's topics interesting. If anyone out there would like to provide insights on a future 5G topic for a future podcast, please reach out to us on social media. Will is at Willtown Tech, and I'm at Anshel Saad. We hope you have a great week, and please tune again next week. Well, actually later this week. And don't forget to rate and subscribe.